Let me give you another example. Imagine you are sitting in a car with your dad. The car's at rest at the moment. Your dad then puts his foot on the accelerator, so the car will accelerate. Let's say the car has an acceleration of 4 meters per second squared. So throughout the whole journey, there will be an acceleration of 4 meters per second squared. So if you look at the table here, well, the acceleration is always going to be 4. Okay, because your dad's always accelerating. He's got his foot on the accelerator, so it's always accelerating 4 meters per second squared. Now, when you look at the speed, when time equals 0, the speed will be 0 because initially the car is at rest. So the speed when time equals 0, the speed will be 0. Now, when time equals 1, let's say 1 second after t equals 1 here. Well, by the meaning of acceleration of 4, it means that the speed will increase by 4 each time. So it was 0 after 1 second. After 1 second, the speed will be 4 because that's what acceleration means. When there's an acceleration of 4, it means there's going to be an increase of 4 every whatever this thing here is, every second. Okay, so an acceleration of 4 meters per second squared. It means forget about the squared for the time being. When there's an acceleration of 4, it means there's an increase in speed of 4 every second. So when t equals let's say when t equals 2 here. When t equals 2, well, the speed was 4, but because there's an acceleration of 4, there's going to be an increase of 4 again. So the new speed will be 8. Now let's look at when t equals 3. So another second after this. Now because there's an acceleration of 4, well, the speed was 8. Now, well, there's an acceleration of 4, so the speed will increase by 4 again. So this will be 12. So the speed here will be 12. Now let's look at when t equals. So let's look at a second after this. Well, the speed was 12, and because there's an acceleration of 4, there's going to be another increase of 16. So the speed here will be 16. And let's look at a second after that. So t equals 5. Well, the speed was 16. Because there's an acceleration of 4, the speed will now be 20. So the speed here is 20. And then well, a second after that, then it's going to be 24. A second after that would be 28. A second after that would be 32. So notice that there's an increase of 4 each time. Where the speed increases by 4 each time. So, well, given our situation here, you sitting in the car with your dad, when there's an acceleration of 4 meters per second here, the situation is like this. So when you try and plot the graph, it will look like this. So imagine you are sitting in a car with your dad. Your dad accelerates 4 meters per second squared. So what that means is this: the acceleration time graph will look like this, always at 4. Okay, it's just a straight line. Now the speed time graph. Let's look at the speed here. This is what we did earlier. Hang on. This is what we did earlier. The speed is here. Time is up here. Okay, so when time equals 0, the speed is 0. When time equals 1, the speed is 4. Okay, when time equals 2, the speed is 8. When time equals 3, the speed is 12. When time equals 4, the speed is 16. So well, when time equals 5, the speed is 20. When time equals well, another second after this, there's going to be an increase of 4. So it's going to be here. And then another second later, there's going to be an increase of 4. So it would be here. And then another second later, there's going to be an increase of 4 here. Because that's acceleration means there's going to be an increase in speed. Because it's an acceleration of 4, there's going to be an increase in the height of 4 each time. So your speed time graph will look like this, a straight line. And because there's an increase of 4 each time, basically the gradient is 4. So the gradient of your speed time graph will be will represent the acceleration. So well, anyway, now let's look at the distance, the distance covered. Okay, imagine your dad is the car is no longer, let's say the car is not at rest. It's already traveling at let's say 4 meters per second. So this is the speed time graph, speed time. So we've got one scenario here where the car is already traveling at 4. Well, it's always traveling at 4, and this one here, this is our scenario here. We started at rest. Okay, we started at rest, and then a second later, well, don't forget, our situation looks like this. Another situation where the car is always traveling is doing it at well, it's already traveling at speed. Now, if you want to know the distance traveled after, let's say, 1 second here, you would work out the area underneath this rectangle. But because our car started at rest, to find out the distance traveled after 1 second, we would need to work out the area underneath this graph. Okay, so there's a difference between these two scenarios here. This scenario here is the car is already doing 4 meters per second. This scenario here, the car started at rest and then it gradually builds its speed up to 4. So when we want to find out when we want to find out the distance traveled after 1 second, we will need to work out the area underneath this graph here. Okay, so the area underneath this speed time graph, it represents the distance traveled. So our scenario is here, not here. Okay, but it doesn't matter if it doesn't matter if it's a diagonal line, because you can still work out the area underneath the graph still represents the distance traveled. So here, if you want to know the distance traveled after 1 second, it will be the area underneath this graph. So the height here is 4, okay, and the across here is 1. So get the across times the height. So across, well, 4 times 1. So get this times this. That will give you the rectangle. But because our line is diagonal, you need to divide it by 2. You need to work out the area of the triangle, really. So it will be 4 times this would be 4 divided by 2, so it will be 2. So the distance traveled after 1 second will be 2. Okay. Now let's look at when time equals 2. Well, when time equals 2, well, if you want to know the distance traveled after 2 seconds, it will be the area underneath this graph here. It will be this area. Well, the height here, the height here is 8. And then you need to times the across here, which is 2. And then, well, if you get 8 times 2, it will give you the rectangle. So we only want half of that, so divided by 2. So the distance traveled will be 2. So the distance traveled after 2 seconds, it will be 8 meters. Okay, and if you look at 3, after 3 seconds, you would need to know the area of the graph here. Okay, the whole area here. Okay, the whole area here. Okay, so the height here will be 12. Okay, and then you need to times it by 3, and then you need to divide it by 2, and all this here comes to 18. Okay, and then after 4 seconds, well, after 4 seconds, you're looking at your speed time graph. After 4 seconds, the area underneath this here represents the distance traveled after 4 seconds. So it would be the up and down here, which is 16. Okay, 16, and then you would times by 4, so it would be 16 times 4, and then divided by 2, and that will give you this. Okay, you don't always need to rely on your graph. You can just quickly sketch it. So let's do 5 seconds. So just quickly sketch it like this. So after 5 seconds, our speed will be 20, okay, and the across here will be 5. So now just get this times this and then divided by 2. It will give you 50. Okay, so come to work out 6. Well, just sketch it. You don't actually need to rely on the graph. Just sketch it. So after 6 seconds, the speed will be 24. That means the height here will be 24. The across here will be 6 because it's 6 seconds. And then, well, if you want to know the distance traveled, it will be the area underneath this graph. So get this times this and then divided by 2. It will give you 72. And then now, if you look at the distance time graph of our situation, it would be this. It will look like this. So after 1 second, look at this. After 1 second, distance traveled will be 2. That's why it's down here, 2. After 2 seconds, the distance traveled will be 8. So you can see there's a bigger increase of 8. After 3 seconds, we would have done 18. So after 3 seconds, 18, and so on. And then let's say after 7 seconds, we would have done well, you and your dad would have covered 98 meters. So after 7 seconds, so 7 here, you would have covered, well, 98. You see, you are covering more and more ground because you are traveling faster and faster each time. So the distance, sorry, this should be distance. The distance, this should be in meters. So the distance time graph would look like this. It would be a curve like this. And the reason why it's a curve is because here, hang on, because well, the 1 second here, you would have covered more distance than the 1 second down here, because your speed is always increasing each time. Your speed is always increasing. That's why that's why further down the line you are covering more ground. It's because your speed is always increasing each time. So let's look at our original situation here. When there's an acceleration of 4 meters per second squared, well, when there's an acceleration of 4 meters per second squared, well, the acceleration time graph will look like this. Okay. Now the speed time graph will look like this. Remember, when there's an acceleration of 4, the speed time graph will look like this. And the gradient, it has a gradient of 4 because the gradient represents the acceleration. Okay, and when you come to look at the distance time graph, it will be a curve like this. This will be distance time. Okay, so okay, I will give you another example in the next video.